Today we discuss the charge to mass ratio of electrons, which are determined by J.J. Thomson with the help of his experiments. What was his experiments? He done an experiment on cathode rays. By applying electric field magnetic field simultaneously. He applied electric field and magnetic field simultaneously on the path of cathode rays, and he observed the deflection takes place in the cathode rays. Already we know that without electric field, magnetic field, there is no deflection in the cathode rays. Deflection means changing in the direction and angle. That is called deflection. In the absence of electric field, magnetic field, there is no deflection. Already we know that in the presence of electric field, the presence of magnetic field, there is a deflection takes place in cathode rays, which consists of electrons. In his experiment to calculate charge to mass ratio, he applied electric field and magnetic field simultaneously on the cathode rays, and he concluded some points with his observations on his experiment. The observations are: the deflection of these particles is always directly proportional to charge on the particle. Means if the charge is present in the cathode rays, nothing but in any rays, if the charge of the particle is higher one, the greater will be the deflection. Next, deflection is also directly proportional to the strength of electric field and the strength of magnetic field. The more electric field but more deflection. If you put the more magnetic field strength, more will be the deflection in the particles and nothing but rays. Like third observation, the deflection of the charged particles are nothing but cathode rays are inversely proportional to the mass of the particles, nothing but mass of the particle. If the mass of the particle is higher one, the deflection will be less. If the mass of the particle will be less, if it is a lighter one, the lighter mass particle, the reflection will be more. So these are the conclusions made by J.J. Thomson in his observations. We can see his experiment again. So just let it is a movement of nothing but a way of cathode rays. By applying electric field, they get deflected this direction, nothing but towards positive direction. Say it is point X. We can observe them on a fluorescent screen. For example, if he applied when he applied a magnetic field, so magnetic field applied this in the deflection is like this, which is exactly opposite to the direction of deflection of electric field. Electric field పెట్టినప్పుడు ఏ డైరెక్షన్ లో డిఫ్లెక్ట్ అయ్యిందో ఆ డైరెక్షన్ కి ఇక్కడ ఆపోజిట్ డైరెక్షన్ లో డిఫ్లెక్ట్ అవుతుంది మ్యాగ్నెటిక్ ఫీల్డ్ పెడితే. సో టేక్ దిస్ పాయింట్ ఈజ్ y. if electric field is 100% equal to magnetic field strength, and electric field strength magnetic field strength equal ga pettamఅనుకోండి, ఈ direction of deflection equal అవ్వాలి. So that indicates nothing but at that time there is no deflection takes place. This take is the point Z. Right, the point X, towards the point X indicates electric field deflection, towards the point Y deflection indicates the presence of magnetic field. The point Z indicates there is no deflection. No deflection takes place. When there is no deflection takes place? When there is no field takes place. That is one choice. But if we apply same strength of electric field and magnetic field, there is no deflection takes place. Okay. So he done this type of experiment for many times. So what is the need to do for many times the same experiment means? He applied the electric field, magnetic field simultaneously, which are perpendicular to each other. అంటే electric field, magnetic field perpendicular గా ఉంటాయి. He applies the electric field, magnetic field, both are perpendicular to each other, and these two also perpendicular to path of cathode rays, nothing but path of electrons. He done this experiment many times by changing the strength of electric field and changing the strength of magnetic field. అన్నిట్లో ఇదే ఎక్స్పెరిమెంట్ రిపీట్ చేసాడు. ఎలక్ట్రిక్ ఫీల్డ్ని మ్యాగ్నెటిక్ ఫీల్డ్ని సైమల్టేనియస్గా cathode rays పైన అప్లై చేసిండు. బట్ వాట్ ఈస్ ద నీడ్ టు రిపీట్ ద ఎక్స్పెరిమెంట్ అంటే he observed their deflections by doing the experiment by changing their electric field and magnetic field by every time, and at last with that observations, with that deflection of the particles, he was able to calculate the charge to mass ratio of electron as 1.7588 into 10 to the power of 11 coulomb per kg. So this term indicates mass, this term indicates charge which is in coulombs. Here E indicates charge, this indicates mass of electron. So this was the calculation of nothing but determination of charge to mass ratio value of electrons by J.J. Thomson. Okay. Next we see the mass of electron, nothing but determination of mass of electron. Here you see mass of electron was determined by millikan with the help of an experiment. His experiment is known as that is called oil drop experiment. With the help of oil drop experiment and with the observations, millikan was able to calculate the mass of electron. Now we see the experiment and details. This is also called oil drop method. So in this experiment, he took a chamber in which an electric condenser is present. These are the two plates are present in electric condenser. Okay. The upper place is positively charged. He passed the oil drops. In the form of mist. So normal water kante oil drops movement koncham less untadi. The oil drop movements become somewhat slow in the form of mist. How do we know what is the form of mist? A mist form lo endante oil drop movement somewhat less untadi. So that oil drops are passed into this chamber with the help of this small tiny hole. And there is an arrangement of telescope is present to observe these oil drops, and he passed the X-rays into the chamber. After the passage of X-rays, the gas present in the chamber is ionized. When X-rays are passed into gas, that is ionized. When X-rays are passed in this chamber, the gas present in this chamber is ionized. Ionized means it becomes ion. There is a formation of some ions. Now these ions are collided with these oil drops. The oil drops coming from the hole are collided. Collided means they just clash with the ions of the gas present in the chamber. And due to that collisions, the collision takes place between the oil drop to the ions. ఈ collisions వల్ల ఏం ఫామ్ అయిందంటే oil drops get charged. So appadaka neutral ఉన్న oil drops they become charged due to the collision of that oil drops with the ions present in the chamber. So ఇప్పుడు oil drops ఏమైనాయి, they becomes charged oil drops. Now the main observation is the velocity of these oil droplets. Velocity of these oil droplets without electric field and with electric field is calculated. The millikan was able to calculate the nothing but determine the velocity of droplets, nothing but velocity of charged droplets. మనకి ఇక్కడ చార్జ్డ్ డ్రాప్లెట్స్ ఫామ్ అయినాయి. ఆ చార్జ్డ్ డ్రాప్లెట్స్ వెలాసిటీ ఈజ్ క్యాలిక్యులేటెడ్ నథింగ్ బట్ డిటర్మైన్ వితౌట్ ఎలక్ట్రిక్ ఫీల్డ్. అంటే ఎలక్ట్రిక్ ఫీల్డ్ అప్లై చేయనప్పుడు వాటి వెలాసిటీ, ఆఫ్టర్ అప్లైకి ఎలక్ట్రిక్ ఫీల్డ్ what velocity. So by comparing these velocity of droplets without electric field and without electric field, he was able to calculate, he was able to determine the charge on droplets. So a velocity without electric field velocity with electric field velocity compared to he he was able to calculate the charge on droplets or droplets పైన వచ్చిన charge ను find out చేసింది. He done this experiment for many times. So what is the need to do the many times అంటే the velocity is depends on electric field. మనం అప్లై చేసే ఎలక్ట్రిక్ ఫీల్డ్ బేస్ చేసుకొని దాని వెలాసిటీ డిపెండ్ అవుతుంది. That's why he done the same experiment. He repeated the experiment for many times by changing the electric field. ఇక్కడ పాస్ చేసే ఎలక్ట్రిక్ ఫీల్డ్ ని దాని స్ట్రెంగ్త్ ఫస్ట్ తక్కువ ఎలక్ట్రిక్ ఫీల్డ్ తర్వాత మోర్ అలా ఇంక్రీజ్ చేసుకుంటూ డిఫరెంట్ ఎలక్ట్రిక్ ఫీల్డ్స్ దగ్గర he was able to calculate the charge on oil droplets. After all these experimental values, after many times repeated this experiment by changing the electric field and calculating the charge on the droplets, he simply concluded that the charge on oil droplets in every experiment is multiple of 1.602 into 10 to the power of minus 19 coulombs. Multiple of 1.602 into 10 to the power of minus 19 coulombs. So therefore, it was concluded that charge of electron, which is a basic particle, is given as 1.602 into 10 to the power of minus 19 coulombs. So this was the oil drop experiment of millikan giving charge of electrons. Next we calculate the mass of electron. Already we know charge to mass ratio. Charge to mass ratio value, that is 1.7588 into 10 to the power 11 coulomb per kg. Say it is equation 1. And we know the mass of, we know the charge of electron. Is equal to 19 coulombs. Say equation 2. So by dividing these two, E by M, we will get the mass. So what are the charge? So this is coulomb per kg. It cancel. So after this cancellation, these values we will get 9.109 into 10 to the power of minus 31 kilograms. So this is treated as mass of electron, which is a negligible mass. Generally the mass of electron is negligible as it is having 9.109 into 10 to the power minus 31 kgs. Or we can say 9.109 into 10 to the power of minus 28 grams. So these are the today topics. Charge to mass ratio value of electron, charge of electron and mass of electron. Okay.